The FAXX program is a long-term initiative by the United States Navy to develop the next generation of carrier-based tactical aircraft intended to operate in environments projected to be far more contested and technologically complex than those faced today. It represents not only a new platform but also a shift in how the Navy envisions future air combat and power projection. Unlike previous generational shifts, the focus here is not just on replacing an older aircraft with a more advanced version, but on redefining what naval aviation must be capable of in the mid-21st century. The aircraft it is intended to replace, the F/A-18E Super Hornet, has been in service for over 2 decades and has undergone several rounds of upgrades. However, there are limits to how much the Super Hornet can be modernized. As global air defenses become more integrated, longer ranged, and more precise, the survivability of fourth-generation aircraft in heavily defended airspace becomes more uncertain. Thus, the Navy has determined that a leap in capability is required rather than incremental improvements. The FAXX is meant to be that leap. The platform is part of a broader concept called Next Generation Air Dominance, but unlike the Air Force's version of that concept, the Navy's program must account for the specific challenges of carrier operations. Launch and recovery from aircraft carriers imposes limits on size, weight, and structure that land-based aircraft do not face. At the same time, the aircraft must have the range and payload to project power over long distances, especially in regions where adversary missile threats have expanded the size of threat envelopes that carriers must operate outside of. Thus, range is not just a desirable trait, it is a requirement for future survivability and mission success. Although the full list of desired capabilities remains classified or only generally outlined, several key characteristics are consistently emphasized in publicly available defense planning documents. These include significantly increased range over current platforms, reduced observability across multiple detection spectrums, improved speed and maneuverability, and a high degree of interoperability with unmanned aerial systems. The FAXX is envisioned to act not just as a standalone weapon system but as the command node in a distributed web of air combat capabilities, effectively controlling or directing other manned and unmanned systems in real time. In this context, the platform must also be built with open system architecture to allow for the integration of new software, sensors, and weapons over time. The need for adaptability is driven by the understanding that future conflicts may demand rapid technological shifts, and a rigid system that cannot evolve will quickly become obsolete. To support this, the aircraft is expected to have modular payload bays, advanced data links, and the capacity to share sensor and targeting information instantly with ships, satellites, and other aircraft. This vision, however, comes with immense challenges, not just technical, but industrial and political. Building a next-generation aircraft that is stealthy, long-ranged, survivable, carrier-capable, and interoperable with future unmanned systems requires technological maturity in multiple domains at once. Such complexity increases both the cost and the risk of delays. Program timelines must be aligned with available industrial capacity, and the entire aerospace sector is already under pressure from multiple ongoing modernization efforts, including the Air Force's separate 6th-generation fighter program, new bomber platforms, and ongoing production of 5th-generation systems. These realities have begun to impact the trajectory of the FAXX program. As of the most recent defense budget planning cycle, the program saw a sharp reduction in requested funding. While this does not signal cancellation, it reflects a pause or slowdown that could delay the timeline by several years. Internally, this decision appears to be driven by a combination of budget rebalancing and strategic prioritization. Delaying development allows the Navy to allocate resources to more immediate needs or to allow technologies still under development to mature before integration into the final platform. Despite these headwinds, there remains consistent acknowledgement within Navy leadership that the program is essential. The current generation of aircraft cannot maintain air dominance indefinitely, especially in scenarios involving peer-level adversaries. Long-range precision weapons, multi-layered air defense systems, and electromagnetic warfare capabilities being developed and fielded by potential adversaries pose real challenges to today's platforms. In that context, proceeding with the development of the FAXX is not simply a matter of modernization, it is one of strategic necessity. Another important aspect of the program is its impact on the overall force structure. The Navy is shifting its thinking about the role of manned aircraft in future carrier air wings. Instead of large formations of traditional fighter attack aircraft, future air wings may include fewer manned aircraft, each with greater capabilities, supported by various types of unmanned systems. The FAXX, in this vision, may be one of the few manned aircraft operating from carriers in the future, assuming responsibility for tasks ranging from deep strike to command and control, while unmanned systems handle tasks like surveillance, jamming, refueling, or precision targeting. From a design standpoint, few details have been publicly confirmed. Industry competition has narrowed, and some participants have exited, suggesting that the focus may be shifting toward consolidation and feasibility. The remaining industry teams are likely working on concepts that push the boundaries of current aerospace design, incorporating lessons learned from existing platforms but also attempting to leap ahead in terms of stealth shaping, propulsion integration, and materials science. The requirement for carrier suitability further complicates these efforts, as any design must withstand the repeated stresses of catapult launches and arrested landings. Looking forward, the timeline for the program remains uncertain. Originally, the Navy had aimed to begin replacing the Super Hornet fleet in the 2030s, but delays may push that target into the later part of the decade or beyond. As this timeline extends, the burden falls increasingly on current platforms, which must be maintained, upgraded, and supported to fill the gap. This creates a cost spiral. Maintaining older platforms becomes more expensive as they age, and delays in next-generation systems compound the problem. In the broader strategic picture, this program represents one piece of a larger effort to maintain global reach and technological superiority in an environment that is growing more complex and more competitive. Future conflicts are expected to be faster, more automated, and more information-intensive. The FAXX is meant to ensure that naval aviation remains viable and dominant in that environment, able to respond to threats from great distances, maintain air superiority in contested areas, and integrate fully with other platforms across domains. Whether the program meets its original timelines or faces further delay, the rationale behind its development remains grounded in the changing realities of modern warfare. It is not just about building a better aircraft but preparing for a different kind of fight, one in which adaptability, integration, and long-range survivability are not just advantages but prerequisites. The ultimate success of the FAXX program will depend on continued political will, technological progress, and sustained investment over the coming decade.